Okay, legends, let's have a talk about polynomial division and factorisation. We're going to go through a few steps here, and I want to start by doing an expansion. A bit of a reminder on expansion, but also this will help lead us into that. How do we divide or factorise polynomials that are bigger than quadratics? So we've got an x minus 1 factor here. This is our linear factor. I'm going to refer to things as linear factors, quadratic factors, things like that. So we get a linear times a quadratic. When we do a linear, which has got a highest order 1, and a quadratic highest order 10, we multiply those together, we're going to get a cubic. That's what we're expecting. So it's always good to have that expectation. Now in the past, I just want to draw your attention to this. In the past with these expansions, you've done a whole range of different things. So maybe you've done area-based thing, or you've done something called the crab clause I've seen, or maybe you've learned it with FOIL. Some of these things break down a little bit when you get to here. So I'm going to stick with the distributive law. And if you get good and you're confident, you might be able to skip a couple of these steps, but it's so important that you make sure you get these things right. So what I'm going to do is I'm going to distribute the first bracket over the second. So it gives me this: x times the second, x squared, plus 2x minus 7, minus 1 times x squared, plus 2x minus 7. Now I can expand each of them individually like a single bracket. So it makes life a bit easier. I'll get my x cubed here, plus 2x squared, minus 7x. And then here I get minus x squared, minus 1 times 2x is negative 2x, and minus 1 times negative 7, of course, is positive 7. And then I'm expecting as a cubic, so I'm going to have 4 terms at most, so I should have some like terms here. So I've got x cubed, that's my only cubic, so that's my cubic term. But here I've got 2x squared, and I've got a minus x squared, that gives me plus x squared. Then I've got minus 7x, minus 2x, that gives me minus 9x. And then I've got this plus 7 here. So there's our expansion. We're going to draw a line under this because we've got an expansion. But what it also means is that I might get a question, I want to factorise this guy. Now I already know the factorisation up here. But let's do this as if we didn't know that factorisation and see what comes out. Talk about a few things we notice. So I'll start with my x cubed plus x squared minus 9x plus 7. And this is where I'm going to introduce to you the factor theorem and the remainder theorem. So this is the factor and remainder theorem. They're two separate theorems, but they're very closely linked. And I will probably be working mostly with factor theorem here. I'm going to bring them both to your attention. So this is my polynomial. And so because it's a polynomial and I'm doing a bit of maths, I'm going to give it a name. And because I'm boring, I'm going to call it P of x. So P of x is a polynomial in x, and it's a cubic here. Okay? Now the factor theorem states that if P of some number here equals 0, well then that number is a factor. So actually let's just write this out better as P of, here we go, alpha equals 0 means that alpha is a root to the equation. It's 0 is the equation, a root or a 0, and x minus alpha is a factor. Now this is really interesting because you might be thinking, what do you mean by this? Well, I mean this. That's a factor. It factorises it with no remainder. There's no plus 6 there. There's no 2x at the end. It's fully factorised into two brackets. So this is a factor. And this is our factor theorem. Might be a good time to pause and write that down. I'm going to clear the board a little bit and we'll carry on. Great. I hope you're still with me and you're dealing with this, because I think we'll get a couple more videos before the big picture becomes clear. So I'm hoping you'll persevere. So we've got P of x equals this. And I'm going to use the factor theorem to try and find a factor to this polynomial to assist me in factorising it. And you'll notice here that I've left this at the top because we wouldn't normally know the answer, but why not leave the answer there? We can refer to it. So P of x equals that. If I wanted to factorise this, I might be told a factor in a question for an exam, but what I could do is just recognise here, and this is how I'm going to do this one. I've got one of these, 7 of those, and 1 and 7 make 9, and then I've got a negative 9 here. So actually this works out quite nicely in that P of 1 equals 1 cubed plus 1 squared minus 9 times 1 plus 7, which is equal to 0. And then according to the factor theorem, therefore, due to the, you probably wouldn't write this, but I'll write it to be clear. Due to the factor theorem, x minus 1 is now a factor. And that means that p of x can be written as x minus 1 times by some quadratic. And I've got some work I can do there. So as we move forward, I'm now going to introduce a way that we could factorise this. We're going to do a bit of polynomial division later on, but I'm going to introduce a way of equating coefficients to factorise this. In the next video, I'm going to formalise how this might look in terms of the big picture. So thanks for persevering with it, and I'll see you in the next video.